Hi, I'm Adam. Welcome back to Godot Game Lab. In this video, we'll add this new battle unit scene to the project so we can prepare the units differently for battles. For now, it will be really simple, but we'll also do a couple animations to make it look a bit nicer. We'll have an animation for auto-attacking, casting the spells, and also a looped animation for moving around on the battlefield. We'll also introduce a new resource called GameState, which will keep track whether we are preparing for a battle or currently doing one. And we'll also need to investigate how that affects the already existing systems. Let's start with the architecture first, shall we? And since this is more like a preparation style of episode, where we prepare a lot of things for starting working on the battle system, the architecture will be fairly simple. One thing we want to introduce is called the GameState resource, which is super simple, and we only use it to differentiate between the two basic states we can have inside the game. One is when we are preparing for a battle, and the other one is when we are actually inside a battle. And while the resource itself is super simple, we still have to investigate and sort of stop and think about how introducing this game state will affect other systems that are already inside our game. Let me give you an example. So for now, with the UnitMover and the game grid system, we can swap units around, we can combine those units and rearrange them however we like. But it would be also super weird if you can still rearrange units on the game grid when a battle is in progress, right? So we have to update those parts of the game and think about whether they need to change their behavior when the game state is in a particular one or not. Another new thing we want to work on is the battle unit scene, which we already covered in the last episode, why I decided to go for a different scene for the battling units. And after that explanation, in this episode we can actually start building that new scene, which we'll use extensively when we are battling. And that's about it. So let's get started. Okay, so I have the project open here, and the first thing we want to do is to collapse our components folder, and with our data folder selected, let's right click on it, create a new folder. We can call this game_state. Right click on that new folder and create a new script. We can call this game_state.gd. Make sure that it inherits not from the node class but from the resource class, since this will be a resource. And we can just click on create, expand the folder and double click on it to open it up inside the script editor. And this script, as promised, will be super simple. The first thing we want to do is we want to create a custom class name called GameState. Then, since this is a super basic sort of state machine, we can just use an enum for this. I called it phase, and we have two constants inside that enum, preparation and battle. And then we just need to have an export variable. We'll call that current phase, which will be of this phase enum type. And for this one, since the resource won't really have any other functions, we can use the inline setter function syntax in GD script, which is super handy sometimes. So what you can do is you can have a colon after the type of an export variable or a variable, and you can have inline getter and setter functions like so. So this will be the setter function. We set the current phase to the value we pass, and we just also want to emit the resources changed signal, so all the systems can be notified that setting this export variable to a new value means that the game state has changed, right? So they can react however it is that they want to react to it. And that's about it. So we can save the script with Control S, but just by adding the script, we still don't have a game state resource added. So let's right click on this folder again, create a new resource this time, and we can search for game state since we added that new class name. And we can just call this GameState_TRES. And if we double click on it, the only thing we can change is the current phase to either preparation or battle. Now, the more interesting part is actually figuring out how this new game state resource affects our already existing systems. Let's do this live instead of providing a ready-made PowerPoint explaining all the stuff. So let's go back to 2D view, press Ctrl+Shift-O, and search for arena.tscn. Since this is the biggest scene we have with all the systems already implemented inside it, we can just look through this and think about whether all of these nodes and systems are affected by this game state changing business or not. So the visuals are definitely not part of this, right? The unit grid itself isn't a part of this either. The sell portal, okay. So can we sell units while a battle is going on? It depends, right? because you shouldn't be able to sell units inside the gameplay area, but you can still sell units that are sitting on the bench. Or at least that's how it goes for most of these games. For the UnitMover, now that is the component that is responsible for moving the units around and registering those drop events at those different places, right? So if I click on the script next to it, without going through all the code, we can see the list of methods here. And we have set highlighters, get player for position, move unit, on unit drag started, cancelled unit drop. So this is definitely a system that has something to do with moving the units around, both on the bench, around the whole screen, and in the gameplay area as well. So this will be different. How so? What we do when a battle starts is we hide all the units inside the game area from the player and instantiate battle units at the same position, right? So what I don't want the player to do when a battle is going on is dragging units from the bench to the game area, right? Maybe it's even easier to show it live. I still have these units, and when the battle is going on, I still want to be able to move Björn around, drop him in a new position at the bench, swap places with another unit. That's still completely valid to do, but what I don't want to allow when the battle is going on is actually dropping these units on the game grid. That's problematic for multiple reasons. Why? First of all, we update the trait UI when the game's unit grid changes, right? So if I were to drop units, even if they wouldn't interfere with the battle explicitly, that would still mean that the trait UI would be messed up from all the changes we are making when a battle goes on. We definitely don't want that. We want this to display the current version based on the game grid when the battle began. So what is completely fine to do in the preparation phase, like swapping units around, we want to disallow this or forbid this when the battle is actually going on. So that's the first system that will be affected by this change, this UnitMover. Okay, what about the UnitSpawner? This is something that we just recently refactored to use this scene spawner component that we added. Again, if I click on the script, you can see that we have just two methods here. One is the get first available area, and one is for spawning a new unit. See, this method here, what it does is it returns a play area, which can be either the bench or the game area, depending on the current capacity of them. So this method prefers the bench because that's the first one inside that if statement. So if the bench is not full, we return the bench. But if it is full, we check if the game area is full or not. And if that's not full, then we return the game area. And if both of those are full, then we return null since there are no available space to buy new units. Well, that works fine for the preparation phase. Again, we have the same problem when the battle is going on. We don't want the trait UI to update, right? So if I start buying units really fast here, you'll see that when the bench is full, units will be added before combining to the gameplay area. And we don't want that to happen when the battle is going on because, again, the trait UI will be updated. Those units will be displayed when the battling units will still punch and kick each other. We definitely don't want this, so we just want to have this error message that your bench is full and you can buy new units when the battle is going on. It's fine in the preparation phase, but again, when the battle goes on, this won't do it anymore. So the UnitSpawner and the UnitMover definitely needs to be changed with this new GameState resource introduced. What about the unit combiner? Again, if we click on the script, we group the units, we update the combinations, queue them, get the triplets and all that stuff. Actually, we want to allow this, right? Because if I'm fighting a battle but buy a bunch of new units, they should still be combined on my bench, right? The unit combiner itself doesn't really need to be bothered with the game state because the unit spawner won't permit spawning new units on the game area anyways. So when a battle is going on, the only place where you can combine units would be the bench anyways, right? Because you can't buy new units anywhere else. And we only have UI nodes. So we are basically done with all the systems, and it seems like there are two places we need to change, the unit spawner and the UnitMover. So I have the unit spawner selected. Why don't we start with that one? Let's click on the script icon again and see how we can update this so we can't buy new units or spawn new units on the game grid when a battle is going on. Now, the first thing we want to update is introducing a new export variable called GameState, which will be a GameState resource, just so we can have access to the current GameState. This is the method we want to update, right? Because we're currently just checking for the bench and the game area, and if the bench is not full, then we return the bench. Otherwise, we return the game area if it's not full. Both of these statements and the code we have here is fine, but since we want to add a new check to this else if we have here, it will be way too long. So we can also do a small refactor here. And what we'll do is we'll introduce 3 new variables. All of them will be booleans. So we basically do the same thing we have here. We just save it to a variable, so this conditional branching logic will be easier to read. And we can just use these new variable names. So we'll just say if not bench full, return bench. Then we can say if not game area full and not is battling, we return the game area. So this is the change we have here, and the reason why I introduced these variables, because otherwise this elif statement would have been too long with these 2 expressions next to each other. So we can just say that if the game area is not full and we are not battling, then we can spawn units inside the game area. If either of these is false, then we can't. So if the game area is full, we can't spawn new units, or when we are battling, we can't spawn units there either. Right? So let's save this with Ctrl S and let's see how we can test this. So let's go back to 2D view, and we have our UnitSpawner, but we have no game state assigned. So let's click on the arrow, press quick load the game state by clicking on it. And now we do have the game state, right? With this resource assigned, if we play the game to test this, game state is set to preparation, right? So if we start buying units real fast, we should still be able to spawn new units inside. And we do. Now, if I sell all these units and set this from preparation to battle, with this change, if I reroll and start buying units again, when the grid is full, we fail this assertion and we have a crash. And that's perfectly fine, because if we take a look at this code, is the spawn unit method. Here we have all our new code, and this method returned null because the bench was full and we were battling. So it returned null, which means that the first available area where we want to spawn the unit is a null value. And we just put this assert statement, so we have an error message inside the debugger saying that there's no available space for the units. And we have actually a to-do comment here that we should throw a pop-up message inside the game instead of crashing it with an assertion. But for now, and that's perfectly fine, which means that the UnitSpawner works as intended, reacting to the current game state. So for the UnitMover, again, let's click on the script icon next to it. So with the script open, let's investigate where we need to put the new stuff in. So if we scroll down, we do have a very long method called onUnitDropped, which is called when the unit's drag and drop components dropped signal is emitted. And we do a bunch of stuff here. We grab the old area index where we started the dragging from, and we have the drop area index, which is the index where we dropped the new unit. And this will be either 0, 1, or -1 when there's an invalid drop, like when we drop it in the middle of nowhere. And when that happens, we reset the unit to its starting position and return from the function. And we actually want to do something similar, but when? How does changing the game state changes this logic? What is it that we want to forbid the player from doing? So I can do something like this, right? So in this case, the index where I start dragging from and the index where I drop the unit will be the same, right? When I drag this Robin and drop him over here, this will be -1, and that's when this reset logic is called, because I dropped him to an invalid position. And when I drag him from here and drop him over there, that's when the 2 indices will be different, and neither of them will be -1. So this will be 0 and this will be 1, right? When I drag him over here and drop him over there, then the starting index will be 1, ending index or the new index, the drop area index, will be 0. So actually the one I want to forbid when the battle is going on is dragging a unit from the bench to the game area, right? This is the thing that I don't want to allow. So what we can do is we can kind of reuse that logic of this one when I drop him to an invalid position by saying that this is invalid too when we battle. So to do this, we need to start by introducing a new export variable first. So let's add a new export variable. This will be a GameState resource, just like it was with the UnitSpawner. So with this added, we can go back to that onUnitDropped method again. And here when we grab the old area index and the one where we dropped the unit, again, we can just introduce a couple Boolean flags, just like we did with the spawner, to make the if a bit easier to read. So we'll need 3 flags. One is called invalid drop, which is basically the same that we have here. So this is where we grab the unit and drag him over to the side. So if the drop area index is -1, it means that there's an invalid target dropping position. And then we have one called bench to game, which means that the old area index, we started from the bench, that equals to 1, and the drop area index is equal to 0. So this means that we are dragging from the bench to the game area, if that is true. And again, we have this is battling flag, which will be the same that we use for the UnitSpawner. We just check if the game state's current phase is equal to this enum value of gamestate.phase.battle. And with these changes, we can just change this if statement from this to saying that we want to reset the unit to its starting position and return from this method immediately in 2 cases. Either when we have an invalid drop, which is the logic we already had there, or when it's true that we are dragging from the bench to the game and we are battling. Because if both of these flags are true, it means that we are again doing an invalid drop from the bench to the game when we are inside a battle. And that's about it. If we save this with Ctrl S, go back to 2D view, because let's not forget to assign that resource. If we select the UnitMover, we have this empty export variable here. Click on the arrow, quick load, click on GameState. And if I remember correctly, it's set to battle from the last test we did. So again, we can save this with Ctrl S and test the game again. And when I buy some new units, I shouldn't be able to drop them over the game area. You see? It resets to its starting position as if I did an invalid drop, just like this, right? I can still move them around inside the bench. I can swap them. I can buy new ones, but I cannot drag them over to the game grid when a battle is going on. And just to check if it works or not, if we select this GameState resource and set it to preparation, we no longer have both of those flags true, so we can do the same thing we did with organizing our units. Awesome. So that's about it for the GameState resource, and we can move on to actually creating the new BattleUnit scene next. If you like my content, please consider checking out my Ko-fi page, where you can donate one time or become a member and get early access to all my content and videos. So let's start working on that BattleUnit scene. Click on the plus sign here to create a new scene. And the root node will be an area 2D. So let's click on other node and search for area 2D. Double click to rename this to BattleUnit. And let's just add a couple new child nodes. So press Ctrl A or click on the plus sign here. Add the collision shape 2D. So we have this warning disappear from here. Select the BattleUnit again. Click on the plus sign or press Ctrl A. This time search for animation player. So we can have all the fighting or battle animations for the units, which we'll do in a second. But for now we can collapse this panel. And we also need to instantiate a bunch of scenes. So let's select the BattleUnit again. But we do need one more component for the sprite. So let's press Ctrl A and search for pegged sprite 2D, which is a component of our own. Let's double click on it, rename it to skin, move this all the way up. And now we have almost everything we need. We just need to instantiate a bunch of GUI scenes we have. So let's select the BattleUnit again, click on the instantiate child scene button or press Ctrl Shift A and search for health bar. Select the BattleUnit again, press Ctrl Shift A, search for mana bar, select the BattleUnit one last time, press Ctrl Shift A again, and search for tier icon. Now if we zoom in, you can see these components are right here. We also use them for the regular units. Just so we keep things organized, I'll just drag the animation player towards the bottom here. And let's start organizing stuff. So for the skin, just so we can see a unit, let's load something for the texture. So let's click on this arrow, quick load, and we can use rogues. for example. Let's not forget that we need to set regioning on. So let's click on region, enabled, and just set the width and the height to 32 by 32. And now it's working. If we change the coordinates, you can see that we scroll through all these different skins. And actually, if we compare this to the units, so if I press Ctrl-Shift-O, search for unit.tscn, you'll see that this offset we applied here because the unit's coordinates are here and the sprite and the visuals are a bit offset towards the right, and also it's pushed down a bit, just so when we move them inside the tile set and drop them, we have this offset automatically applied, which makes it look nicer, like they're standing on that tile. But for the battle units, we will be applying those offsets through code because it makes navigation code much easier for the unit AI later on. So we actually want them centered like this, which means that we need to move around the GUI nodes a bit. So let's select the health bar, go into move mode by pressing W, and let's move it around a little bit to something like this. Select the mana bar, do something very similar. And finally, do the same for the tier icon. And we do have a bit of a hiccup here because this should be rendered in front of the health bar and the mana bar. And I believe when last time we set the Z indexing for these nodes, the Z indices are set to 1. But I think for the tier icon, it's set to 0. So if we set this to 1 as well, then it will be rendered in front of the mana bar, which looks a lot nicer. Okay, we have the GUI nodes in place now. Let's go back to select mode by pressing Q. And let's not forget that we need to add a shape to the collision shape because we have this warning here. So let's click on this empty arrow and add a new rectangle shape 2D. Click on that shape resource and I'll just set it to 36 by 36. So it's a bit bigger than the sprite. And that about looks right. If we select the skin, I think it's just a dwarf that is this small. Yeah, it looks perfectly fine like this. Okay, so now we have all the nodes we need. Let's not forget to actually save the scene because it's still unsaved. So press Ctrl S, go back to the root folder, go inside scenes, and I'll create a new folder. Call this battle_unit, and BattleUnit.tscn is fine. And we can create the animations next. The first animation we'll do is the attack animation. So select the animation player, click on animation, new, let's call this attack. And I'm no animator by any means. So these will be just very simple like squash and stretch principle, quick snappy animations to make the game look a bit nicer. Change the length of this attack animation to something way shorter like 0.2 seconds right here. Let's change the snapping option to something like 0.05 and click on this icon here to toggle snapping to the timeline cursor. And what this does, if I press and hold Ctrl and zoom in, when I start dragging the cursor, it will snap to these 0.05 second intervals. And if we select the skin is the one we want to animate. And for the attack animation, we want to go to new 2D transform and we'll animate two properties. One is the rotation. So let's click on this key next to it. We want to create the reset track for it. And we also want to animate the scale. So do the same. Now we have two keyframes at 0.0 seconds. And I actually want the attack animation to start from a frame, which is already like a preparation kind of thing for the attack. So let's click on the rotation keyframe and set it to something like -15 degrees. And for the scale, we can click on this link to unlock the ratio of these values and stretch it across the x-axis like this and squash it on the y like so. And so we start from this anticipation kind of frame. And just so the animation looks a bit nicer, we can change these tracks interpolation mode from linear to cubic for both of these tracks. Snap to the next position in the timeline. We can right click on this keyframe, and we can say copy keys. Right click here and say paste keys. So we will just copy this new key right here. And I actually want to invert those values. So then it will be squashed on the X and stretched on the Y. So it produces this kind of very quick and snappy squash and stretch animation. And at 0.15, we want to rotate the other way around. So let's right click on the rotation keyframe here, copy keys, paste them right here. And so we want to swing to the other way. So now it looks like this. But we also want to change the scale again, or we can just click on insert key. And we change this to 0.9 and 1.1. So it's a bit like it starts coming back to its normal ratios, right? So you can see this slight change from this very squashed and stretched version. And at the end of the animation at 0.2, what we actually want to do is inserting both keys and reset back everything to its normal. So 0 rotation and 1 scale on both axes. So now the attack animation looks like this. And I think it's pretty good for programmer art because I'm not a skilled animator whatsoever, but I think this looks passable at least. So that's all we need for the attack animation. We also need to do one when we cast the spell that the unit can do. So let's click on animation, add a new one, and we'll call this cast. And this will be a bit longer. So when the units perform their skills or spells, we'll take this 0.3 seconds. And this time we'll also want to select the skin and we want to animate the scale again. We don't need to create a reset track for it because we already have one. And we also want to animate the modulate property. So we can just apply some light coloring. So let's go to canvas item, visibility, and click on modulate. And we do want to create a reset track for this property because we don't have one yet. Click on create. And you'll see what the reset animation does is it plays in the editor as well. So if you click on it, you can see what it does is it resets the whole thing if the unit is stuck inside an animation. When you edit these animations, you can end up in these weird positions. And if you ever click on reset, it will reset all those to their original places. So for the casting animation, we want to start from the original scale, so 1 by 1. We want to start from the natural modulation, so the original texture version. And here I think actually 0.05 is a bit too big of a leap. I want a slightly different curve to the whole animation, so I'll just change this to 0.02. And at 0.08, we can create a new keyframe for both of these. Squash the unit real heavily. So it will be 1.3 on the X and 0.7 on the Y. So it's squashed real tightly. And I want to use for the color value, I just use a very bright yellow color, I think. Something like this, yeah. And the biggest part of the animation will be this center piece. When the color changes gradually, we go all the way to like 0.22. The color will be the same, but we invert this squash. So the X will be 0.7 and the Y will be this very big, very accentuated 1.3. So what this looks like is like this, right? So performing this casting animation with projectiles and stuff, it will look fine, I think. And at the end of the animation, again, we want things to go back to normal. So we'll insert 2 keys. The scale will be 1 by 1. And the value of the color will be just white. So we can move this all the way up. Again, just so it looks a bit nicer, because right now it looks not as bouncy as I'd like it to be. I just changed both of these to cubic interpolation instead of linear. Now it has this snappiness, this bounciness to it, right? So this is when the unit casts its spell. And that's about it for the cast animation. And we need one final animation. So click on animation and new. Let's call this move. And the move animation will be a bit different because we actually want this to loop. So let's change the duration to something like 0.55 is what I used in my reference project. Let's click on this button to toggle animation looping and select the skin. And we want to animate 3 properties. We want the rotation again. There's no need to create another reset track. We want the scale. And we also want the skew to make it like really cartoony. And create a reset track for the skew because we don't have one yet. Again, you can change these to cubic if you'd like. And we can start building this animation. We can change back the snapping to 0.05 because this is granular enough for a much longer animation. I just press and hold the control and scroll wheel out, so we have the whole animation inside our timeline visible. And we have the starting position of 0 rotation, the original scale, and 0 skew, which is perfectly fine. This is where we want to start the animation. So at 0.15, what we can do is we can duplicate all the keyframes at once. So if I draw a rectangle with my mouse button that selects all 3 of those keyframes, and do right click next to the cursor and duplicate keys, they will duplicate all of these at once. And we can do something like minus 10 degrees of rotation, a slightly smaller scale, so like 0.9 on both axes, and skew the whole unit by like minus 5. Yeah, you can see that little skew. And just so it goes like this ping pong animation, we want a frame in the middle of it where it goes back to its original. So let's select all 3 of these values, right click, duplicate them, and at 45, at 0.45, we want to do the opposite what we did here. So let's just select these 3 now, duplicate those keys, and we go from -10 to 10, 0.9 can stay the same, and from -5 skew to +5. And with these small keyframes, we have this very cartoony move animation, right? And it loops perfectly fine like this. I know it looks a bit silly, especially for pixel art, but I just wanted to do something. Like for pixel art games, probably you would do frame by frame animation for all the units, which is a whole different story, but for the purposes of the course, this will be much better to look at than if everything was stationary. Right, so we have the animation sorted out. We can save this with Control S, and the cool thing about this kind of solution is it's very time efficient, because now if we change the skin coordinates to a different unit, we basically have the same animations ready to go. So if we have Arthur here, the move animation will work just as fine. The attack animation can play as well, and the cast animation can play as well. So this will work for all the units regardless what skin they currently have. Let's save the scene by pressing Ctrl S. And now we need to attach a script to the battle unit. For now, it will be really simple, but we will keep adding to it as we progress with all the systems related to battling. But we do have a problem even now. See, we have the skin and we have the texture attached to it, and we can set the coordinates, but we want to use the same battle unit for both the enemy characters and units and the players, right? Right now we only have the texture for the rogues, but if I press quick load here, you'll see that we have a sprite sheet called monsters and we have another one called animals. So the problem is that we only have one of these available. And also in terms of the battle systems we have to differentiate between the two teams. So the player's team and the enemy team, right? So before we can actually do the battle units script, we need to do a slight refactoring or adding new functionality to the UnitStats resource. So let's go to the script tab, press Ctrl-Alt-O and search for unit_stats. So we want to avoid redoing anything as much as possible, and UnitStats and the battle unit scene itself should be available for us to use both for the enemies and the player units, right? Because they are kind of doing the same thing, they just belong to a different team. So what we do is we introduce a new enum called team, which can be either player or enemy. And now to handle this situation of having the different sprite sheet, there are multiple solutions. Probably the easiest solution would be to merge the tile sheets together to one sprite sheet called units, and then you should be good to go with one texture assigned. But I didn't want to go into sprite sheet merging because that's much more art and asset management related. So we'll just solve this by code for now, which is pretty easy to do as well. We'll just need to have a new constant, which will be a dictionary. We call this team sprite sheet, and the keys will be the team enum values. For the player and the enemy, we'll have two preloaded textures. So if it's a player unit, it will use this sprite sheet. If it's an enemy unit, it will use this sprite sheet. Again, it's a bit more complicated than just merging the sprite sheets into one file, but works just as fine. And to make sure that we know that this UnitStats resource is for an enemy or for the player, we actually need to have a new export variable where we set this team enum value. So if we scroll down, we have two categories, one for the data for the unit and one for the visuals. And we can just add a new category called battle, which will be extensively used throughout this second season because there are a bunch of data connected to battling, right? Damages and all kinds of numbers like health and max HP and mana and all that stuff. But for now, we will only have one value, which will be a team enum value, either player or enemy. So if we have this, we should be ready to go. Let's save this with Ctrl S. And now we can actually go back to 2D view and create the script for the battle unit itself. Let's select the root node, the battle unit node, click on the attach script button. BattleUnit.gd is fine. Click on create. And let's see how we can do this for now. First of all, we'll provide a custom class name called BattleUnit. Then we'll have one export variable for now for the UnitStats resource with its own setter function. Then we'll have a bunch of already variable references for the skin, the health bar, the animation player, all those nodes we added. And then we can create that setter function. First of all, we'll set the value to its new value. And then if the value is null or the node is not ready in the scene tree, then we can return from the function immediately. This is instance valid for the tier icon, is the same kind of logic we applied in the last episode for circumventing that await ready signal code we used earlier. If you take a look at this, this is the last one that will be ready in the GUI that we actually need before doing any kind of setter logic. But if we are ready, what we do is we create a duplicate of the resource, of the UnitStats resource, to make sure that we don't change anything in the original one, like the max HP or anything like that. Then we set the collision layer based on the team that is assigned to it. This is not strictly needed for now. This is needed for much later down the line. So when we do hitboxes and hurt boxes and damage management for the battle. Remember, we are an area 2D, right? So we extend from the area 2D class. So we need to use a different layer for the player team and the enemy team. And we can use the stats.team for this, because if I press and hold Control and click on it, you'll see it's an enum value, and enum values have default numbers assigned to them. So the first one will be 0 and the second one will be 1. So we need to add 1 to it, because if I go back to 2D view for a sec, if we select the root node and go to collision, you'll see that we have layer 1, which has the value of 1, and we have layer 2, which has the value of 2, right? So if I add 1 to that enum value, 0 plus 1 is 1, which puts it on layer 1. And if it's an enemy unit, 1 plus 1 is 2, which puts it on layer 2. So this way we can differentiate between them. Again, this is not really needed for now. It's just sort of future-proofing the code a bit when we get into managing damage and all that kind of interesting stuff. Then we can do all the visuals based on this stats resource. For the Pack Sprite 2D, we set the texture based on this sprite sheet dictionary we just added in the UnitStats class. And this will use the team export variable of the resource. So if it's a player unit, it will use the rogues.png, which is preloaded there. And if it's an enemy, it will use the monsters.png. Then we apply the skin coordinates for the pegged sprite 2D component. And we also need to set a flip, a horizontal flip, because when the units will battle, we want the player's units to face towards the right, and we want the enemy units to face towards the left, so they are standing facing each other, right? So we want to flip based on the team again, right? And since units are facing to the left by default, this is fine for the enemies, but if it's player units, then we want to flip them over horizontally. So that's what we do here. This will be true, that we want to horizontally flip when the team is equal to the player team. And finally, we set the stats export variable on the tier icon scene to make sure that it displays the correct icon. If we save this and go back to 2D view, we can test if the battle unit works or not. Right now we have an empty stats resource, but that should be fine. So if we run the scene, you can see that the guy is right there. Still no error messages. Just so we can see what's going on a bit better, for now we can go into move mode by pressing W and move it around a bit. Yep, still fine. And if we change that stats resource, we can press quick load and set it to, I don't know, Robin. It will update immediately. And you can see that the flip H is working as well because he faces towards the right now. And you can see that the layer is set to 1, which is fine for player units as well. If we stop the game, we can reset the position because I just wanted to show you that it works. And that's all we needed to do for now for the battle units, but as I said, we'll keep expanding on it as the project grows. And that's it for this video, and I'll see you in the next one. Bye bye.